All right, so hello. We today are going to be talking about the quadratic formula, which we've done already, but today we're going to have complex roots. So what that means is our answers are going to have i's in them, okay? We're going to be able to write them in a plus bi form. All right, so the quadratic formula is at the top of the page for us. I think most of you guys seem to have that memorized, so I'm going to just kind of go right past that, and let's just take a look at number one. Now, the directions say to solve each of the following equations using the quadratic formula and write your answer in simplest a plus bi form. All right, so let's take a look at number one. So with number one, we are first, let me just get my pen here. We're going to just plug it right into the quadratic formula, right? Once the equation's set equal to 0, which it is, we know that our a is 5, our b is -4, and our c is +3. So if you want to write that out, go for it. But you don't have to, that's up to you. Okay, so we're going to write x equals, right? With the quadratic formula, we always want to write whatever variable it is you're solving for before the equal sign. You don't want to forget that. If we have an equation, we need an equal sign. All right, so x equals, so -b. So -4 would be +4, and then plus and minus the square root of b squared. So you can either write -4 in parentheses squared, or if you want, just jump right to it. -4 squared is 16. And then minus 4 times a, which is 5, times c, which is 3, and that entire thing is going to be all over 2 times a, so 2 times 5. All right, so let's figure out what we have going on here. So we have x equals 4 plus and minus, okay, the square root of something. So you guys have to figure out what that is equal to. So 16 minus 60, which would be -44. Okay, so under the radical, we have -44. And then over 10. Now, in the beginning of the year when we did the quadratic formula, we knew if we had a negative under the radical, we made a mistake. But now that we've learned that you can have negatives under the radical, right? It's called imaginary numbers. Now we're going to work with this. All right, so first of all, I'm going to break this up off to the side, okay, just so we don't make a whole big mess within our equation. So if I have radical -44, okay, first of all, 44 is not a perfect square. So I'm going to need 2 separate radicals for the 44. And then also, since we have a negative under it, we need to include a third radical for that negative. I'm going to put it right there, -1. Okay, now 44. The biggest perfect square that divides evenly into 44 is 4. So 4 times 11 gives me 44. So I'm going to make this a 4 and this an 11. Okay, so now, since the square root of 4 is 2, and since the square root of -1 is I, I'm going to actually bring it over here, right? I can rewrite this and this as 2i. And then let's bring down the radical 11. Okay, so again, the square root of 4 is 2. The square root of -1 is I, and I brought down the radical 11. You always want to put the 2 and the I in front of the radical. That way it doesn't look like, is it under the radical? Is it not? Okay, the 11 is the only thing under the radical. Okay, so now let's go back to our problem over here. So we can rewrite this as x equals 4 plus and minus. Well, since radical -44 simplifies to 2i radical 11, let's rewrite that as 2i radical 11. And that'll be over 10. Now remember, you don't simplify any of the numbers on the outside of the radical until you're done simplifying the radical, which now we are done simplifying the radical, right? We finished that. So what we're going to do is we're going to look at these 3 numbers and say, well, what's the biggest number that divides evenly into all of them? Well, 2 is. So if I divide 4 by 2, that'll give me 2. If I divide 2 by 2, that'll give me 1. So I could write 1i or just I, and then bring down the radical 11. And then 10 divided by 2 is 5. Now, if the directions just said to solve, this would be fine. But because they want it in a plus bi form, what they want you to do is they want you to break it up. So you could clearly have a number that represents a, that represents the real component of it, and also so that you clearly have a number that represents b times I, the imaginary component of it. And it's super easy to do. All we have to do is basically take what's in front of the plus and minus and divide it by the denominator. So we'll have 2 over 5, and then plus and minus, and you can take what's after the plus and minus and divide it by 5. Okay, so it'll leave us with x equals 2 over 5 plus and minus I radical 11 over 5. So all you're really doing is you're just breaking this up. So you're individually dividing the 2 over 5, and then you're taking what's after the plus and minus and putting that over the 5 as well. Okay, this is considered a plus bi form. Now, if you look at this, this is your a. The radical 11 over 5 is your b, and then here's your I. Some people like to also rewrite it so that the I is at the end. So that would give you 2/5 plus and minus. And if you want to have the I at the end, see how the I is at the end, just take the radical 11 over 5 and bring it in front of the I. So we could write this as radical 11 over 5 with the I at the end. Okay? So here's our A, here's our B, and here's our I. So this is A. It's really plus and minus BI form. All right, what I'd like you to do is try out number 2. Actually, you could try out 2 through 4 on your own. So 2, 3, and 4. And after you do each example, like do number 2, hit play, check your work. Do number 3, then hit play and check your work. And do that for number 4 as well. All right, so with number 2, before we can do the quadratic formula, remember you have to have one side of the equation set equal to 0. So if I take this 9 and move it to the right-hand side, the left-hand side of the equation, it becomes a positive 9. So I can rewrite this as 2x squared plus 8x plus 9 equals 0. Okay, so we could see my A is 2, my B is 8, and my C is 9. So when I plug it into the quadratic formula, I have x equals, so negative B would be negative 8 plus and minus the square root of B squared, so 8 squared, or if you prefer to just write 64, that's fine too, minus 4 times A, which is 2, times C, which is 9, and that whole entire thing is going to be over 2 times A. So 2 times 2. All right, so that gives us x equals negative 8 plus and minus the square root of, and you just want to figure out what this is equal to, so 64 minus 72 is negative 8, and that's going to be over 4. All right, so I'm going to simplify this radical off to the side just so we don't have to mess with in our problem. So if I want to simplify radical negative 8, since 8 is not a perfect square, I need 2 radicals for that, and then you need a third radical for the negative 1, right? So 8 I can break up into radical 4, radical 2. All right, and since the square root of 4 is 2, and since the square root of negative 1 is I can rewrite this, so I'll write here as 2I radical 2. So where I see this radical negative 8 in the problem, I'm going to replace it with 2I radical 2. Okay, now we can start to simplify. Remember, we can't simplify this negative 8 and this 4 until we simplify our radical first, because we need a number out here too. We have to be able to simplify all 3 terms. We want to say what's the biggest number that divides evenly into, don't even worry about the sign, 8, 2, and 4. So it's going to be 2. So I'm going to rewrite this as x equals, well, negative 8 divided by 2 is negative 4. And then bring down the plus and minus. 2 divided by 2 is 1, so 1I, or just I, and bring down the radical 2. And then 4 divided by 2 is 2. Okay, and then when we're done simplifying, we want to break it up into A plus BI form. So remember, we're going to individually divide the negative 4 by 2, and then what comes after the plus and minus by 2. Okay, so I'm going to rewrite this. And you know, honestly, if it helps you to circle it like this, go for it. Okay, kind of makes, look, it kind of looks like a heart, right? Okay, so we have negative 4 over 2, and then plus and minus I radical 2 over 2. Now here's the deal, look at this, this still simplifies, and if something simplifies, you want to do so, you don't want to leave it like that. So negative 4 over 2 simplifies to negative 2 over 1, or just negative 2, right? Isn't negative 4 divided by 2 just 2? Okay, so I'm going to rewrite this as negative 2 plus and minus I radical 2 over 2. Okay, so this is a plus bi form. Here's my a, this is my real component, and here's my b times I. Here's my imaginary component. If you prefer to have it so that the I comes at the end, so you can clearly see that your a is negative 2 and your b is radical 2 over 2 and have the I at the end, you can rewrite it if you prefer. Let me just put x equals in front of this. I always like to have x equals because that's what we're solving for. You could write negative 2 plus and minus, and you could just bring the radical 2 over 2 in front of the I. So radical 2 over 2 I. Okay? So you could write it, I'm going to put or. Either way is fine. All right, so number 3, what is going on in this equation? There's a lot going on. Well, okay. So first of all, I'm seeing an x to the 4th. And if we have an x to the 4th, that is not a quadratic. So if this is under the right category of the quadratic formula, this is going to have to somehow cancel off. All right, well, I see parentheses on this side. So let's first distribute. So, all right, let me bring down the left-hand side of the equation. And then on the right-hand side of the equation, all right, so 2x squared times 3x squared is 6x to the 4th. Now I see how those are going to cancel. And 2x squared times negative 1 is negative 2x squared. Now, we know we want to get one side of the equation set equal to 0. So, I mean, some of you can just look and say, look, if I have the same thing on both sides of the equation, these 6x to the 4th are going to cancel. If you don't see that right away, then just basically subtract the 6x to the 4th from the right side as well as the left. Oop, that's a minus sign. That actually looks like an addition sign. Let me change that. And then we're also going to add the 2x squared because we want to get, I'm going to line that up under my x squared term, we want to get one side of the equation set equal to 0. So on the right-hand side, these cancel, and it is equal to 0. Okay, we're left with 0. On the left-hand side, the 6x to the 4th minus 6x to the 4th canceled, which is good. We wanted to get rid of that, right? If we want to do the quadratic formula, we need a quadratic, which means our biggest exponent is a 2. And then here I can combine these to give me 6x squared. And then I'll just bring down the minus 3x plus 2. So now we have a quadratic, and it's set equal to 0, so we could jump right into the quadratic formula. All right, so we have x equals. Now, our a is 6, our b is negative 3, and our c is 2. So we're going to do x equals negative b. So negative 3 would be positive 3 plus and minus the square root of negative 3 squared, which is 9. If you want to just jump right in and write 9, you can. Or you could put negative 3 in parentheses and square it. And then minus 4 times a, which is 6, times c, which is 2. And that whole thing is all going to be over 2 times a, so 2 times 6. Okay, so let's keep going. X equals 3 plus and minus. And then you want to figure out what that's equal to under the radical. Okay, you can plug that in a calculator, do it in your head, however you want. But you wind up getting negative 39 over 2 times 6 is 12. Okay, I'm going to simplify the radical negative 39 off to the side. All right, well, here's the deal. 39 is not a perfect square. And there is no perfect square that divides evenly into 39 other than 1. I mean, if you want to break this up into radical 1, radical 39, you can. But the square root of 1 is just 1, so it's kind of pointless. I'm going to actually erase that. I'm going to erase this part of it. But we do have to create a separate radical for the negative 1. And if you recall, the square root of negative 1 is equal to I. So this is equal to, remember, we put the I in front of the radical. That way it doesn't look like it's underneath it. This is equal to I radical 39. We couldn't get anything out of this radical other than the negative 1. And that happens. Okay, so I'm going to rewrite this as x equals 3 plus and minus I radical 39 over 12. Now, since this is a 1 in front of the I, there's no number that divides evenly into 3, 1, and 12. I mean, no whole number, I should say. So we're done simplifying. So now we're just going to break it up into a plus bi form. Okay, so again, if you like to like circle this, let me change the color. I'm going to make it a different color. You want to circle this, so you have 3 over 12 plus and minus I radical 39 over 12. You can do that. All right, let me go back to blue again. So we have x equals, so 3 over 12 plus and minus. You could either write I radical 39 over 12, or if you prefer to take this I, I'm actually just going to do it right here. If you prefer to take that I and throw it behind the fraction, you can write that as well. Now, if you notice, we're not done, because doesn't this right here simplify? 3/12 simplifies to 1/4. So my final answer, I'm going to have x equals 1/4 plus and minus radical 39 over 12 I. Okay, and that's it. If you prefer to have the I, where it was in front of this radical instead, you can do that as well. Okay, and then number 4, I think this one personally was a little harder just because we're dealing with a fractional equation. But we know when we do that, first thing we want to do is make everything into a fraction. So I'm going to put this 2 over 1, and let's find a common denominator. So our common denominator is going to be 3x. All right, now this first fraction is missing the x. So we can multiply, let me change colors here. So we can multiply top and bottom of the equation by x. Okay, the middle fraction has the x, but it's missing the 3. So we can multiply top and bottom of this fraction by 3. Where can I squeeze that, I guess, right in front? There we go. Let me just erase this because I'm kind of blocking that x there. Let me move that 3 over a little. Sometimes I like to rewrite it because it gives me more room to fit everything. All right, now if we look at this last fraction, it just has the 1. It's missing the 3 and the x. So I have to put the 3 and the x in the denominator, right? 3x, you could just put it all together. But if I put that in the denominator, I also have to put it in the numerator. So now if you notice, all of our denominators now say 3x. Okay, so when that happens, we're allowed to take them and just cross them right off. All right, so I'm going to rewrite my numerator, and then we're going to go solve. So we have an x times, I'm going to put the x plus 3 in parentheses, okay? So I know here I have the x in the parentheses, but I need this x plus 3 in parentheses. That way I know to distribute the x to both, okay? And then plus, same thing here. I have 3. This x plus 3 has to go in parentheses because I'm distributing the 3 to both. And then equals just 2 times 3x. All right, so let's solve this. So I get x squared plus 3x plus 3x plus 9 equals 2 times 3x is 6x. All right, so I'm going to set the right-hand side of the equation equal to 0 by subtracting 6x. And then that gives me x squared. Well, look at this. Positive 3x, and negative 6x. They actually all cancel off. So I guess I'm just going to bring down this plus 9. And then equals 0. Now, the question does say to use the quadratic formula to solve, so we are going to have to use the quadratic formula. I just want to point out, if it did not say that in the directions, a really fast way to solve this, so I'll do it in a different color. I'll do it in red, okay, would be to just basically subtract 9 from both sides of the equation, leaving us with x squared equals negative 9. And then you would take the square root. We know a square and a square root cancel each other out, so leaving with x equals. Now, this square tells us we have 2 answers. That's why when we do this, we write plus and minus. And then 9 is a perfect square. The square root of 9 is 3. And then we still have to worry about this negative 1. So ready, we could write this out. We could break this up into the square root of positive 9 times the square root of negative 1. Now, like we said, we know the square root of positive 9 is 3. And the square root of negative 1 is just I. So our answers are plus and minus 3i. Okay? Now, Unfortunately, the directions, if you go back to, the other page, it says to solve each equation using the quadratic formula. So what I did in red isn't going to work. So what I'm going to do is I'm going to come back over here. And, that was a +9. I'm going to solve this equation using the quadratic formula. Okay, so the quadratic formula. Now here's the deal. If you look, we're missing a term. We're missing the middle term with the x on it. So I'm going to write this out. I normally don't, but the a is the number in front of the x squared, which is 1. The b is the number in front of the x. Since we don't have a x term, the b is 0. And then the c is the number that's all by itself, which is the 9. So let's plug this into the quadratic formula. All right, so we're going to have x equals negative b, so negative 0, which you don't have to put a negative in front of a 0. 0 is just a 0. Plus and minus the square root of b squared, so 0 squared, minus 4 times a, which is 1, times c, which is 9. And then that whole thing is going to be over 2 times a, so 2 times 1. All right, so now we have x equals 0 plus and minus. And we have to figure out what this is equal to under the radical. So 0 minus 36 would just be negative 36 over 2 times 1, which is 2. All right, so we have x equals 0 plus and minus. Now, radical negative 36. All right, I'm kind of running out of room, so let me just kind of change color so it doesn't blend in. I'll do that off to the side. So radical negative 36. Well, 36 is a perfect square, so I only need one radical for that. The 36 will go in there. And then I need another radical for the negative 1. Okay, so the square root of 36 is 6, and the square root of negative 1 is I. So I can replace this radical negative 36 with a 6i. Okay, so we have 0 plus and minus 6i over 2. All right, so x equals. Now, let's be honest, this 0 we don't need. Isn't 0 plus 6i just 6i? And isn't 0 minus 6i just 6i? So really, this 0 we don't need here. So we have a positive and a negative 6i over 2. And since 6 divided by 2 is 3, we can rewrite this as positive and negative 3i. Okay, and look at that. We get the same thing as when we solved it without the quadratic formula. Now, I just want to point out, it does say to write it in a plus bi form, even though we just have an imaginary component here. If you want to write 0 plus and minus 3i, you can. But the way we have this written, it's implied that the a is 0. You do not have to write it. Okay, at this point, the regular and lab classes, you guys are done. The honors class, you guys are going to try out numbers 5 and 6, and then you're going to check your work with the answer key on Google Classroom.